This is Unit 3 review for pre-calc, page 271. This is the fourth video. I'm going to do the last part of the homework, 97 through 147 here. So 97 through 104, that section, it asks you to rewrite it, okay, as you solve. So in order to solve these, I should say, you have to rewrite it. So number 97, you're going to rewrite that as log base 8 of 512, and when you solve that, you get 3. Number 98, you're going to rewrite it as log base 6 of 1 over 216, and you get negative 3. Again, notice here for 97 through 100, they were all given as exponentials. We want to solve for the exponent, so we need to rewrite it as a log. Have those in blue here. 99, the base was e, so it gets its own special. It's ln of 3, which is 1.099, and 100 is ln of 6, which is 1.792. Now 101 through 104 is the opposite. It's given to you as a log, so you have to rewrite it as an exponential. So 101 becomes 4 squared, which is just 16. 102 is 6 to the negative first, which is 1/6. I'd prefer that as a fraction, not the decimal. 103 is e to the fourth, which is 54.598. Again, ln has an e. And 104, same idea, e to the negative 3 comes out as 0.050. 105 through 114 here, this section, again, it's asking you to solve for the x. So if it's given to you as an exponential, which each one of these was given to you as, you need to rewrite them as a log after you get the exponential by itself. 105 was by itself, so you just rewrite it. Ln of 12 is 2.485. 106, again, just rewrite it. Ln of 25, this time equals 3x. So after you do ln of 25, you have to divide by 3. You get the 1.073. 107, you just set the 4x equal to the x squared plus 3. This is just 1-to-1 property. Whenever you have an x squared, you always want to solve or set it equal to 0 to solve. So you subtract your 4x, factor it, x minus 3, x minus 1. You get x is 3 and 1 for your two answers there for number 107. All right, 108, you want to first divide by the 14. So I wrote this one out. Divide by that 14. You get 40. Rewrite it. Ln of 40 is equal to 3x plus 2. Find ln of 40 on the calculator, subtract 2, divide by 3. You get 0.563. 109, very similar. You first want to subtract this 13. So 35 minus 13 is 22. Rewrite it, or log base 2 of 22 is equal to the x, and solve, you get 4.459. 110, 6 to the x minus 28 equals negative 8. You're going to add your 28 to the negative 8, get 20. Rewrite log base 6 of 20 equals x. You get 1.672. 111, divide by your negative 4, so you get 17. Rewrite it, log base 5 of 17 equals x. These are the same types of problems over and over again, just getting the exponential by itself, then rewriting it as a log, then simplifying it. 112, same idea, divide by 2, you get 85. Actually, we get 95 there. That is a typo, so I'm going to fix that. 190 divided by 2 there is going to be 95. And then you're going to do the log base 12 of 95, and that comes out to be the 1.833. So let me just fix that, make these correct. All right, I'm just going to double check my answer right now. 112, 1.833 is correct. All right, continuing on there, we now are going to do 135. These last three problems, 135, 145, and 147, were problems. So 135, it says it's compounded continuously, so that's the PERT. All right, it says how long will it take for it to triple. So it gave you 7550. You multiply that by 3, and that's where the 226650 came from. All right, the interest rate is 7.25, so that's where the 0.0725 comes from. Divide by the 7550, you get 3. Now you rewrite it. So this is exactly what we were just doing in those previous problems. You just had to fill it in the beginning. So you rewrite ln of 3 equals to 0.0725t. Solve it, you get 15.153. 145, very similar. In 145, they gave you the equation here, and they said they want to know when's the population going to reach 4.5 million. So notice I don't have this as 4.5 million, I have it as 4,500, because it says in the beginning that the population here is given in thousands. So 4,500 is going to be the 4.5 million represented in thousands. So I know it's a little bit confusing. Okay, so there are, if you multiply 4,500 here by 1,000, you get 4.5 million. So this is what we started with. That's the population. This is my initial population. It gave me all the rest of it. So now I'm just going to solve, divide. This comes out, I'm assuming, as a decimal. I didn't actually figure it out. When I rewrite this, it's going to be ln of that answer. You can see I wrote that there in blue. Of that 0.0135, divide by that 0.0135, and you get 18.637. It had asked what year would this occur. It started in 1990, so that's 18 years after 1990, so that would be 2008. Looks like about halfway, a little past halfway. Last one, 147, there's two pieces to it. You have 10 grand, you're depositing that compounded continuously, so that's PERT. It wants to know when will it, or it says it will double in 5 years. So if it's going to double in 5 years, that means I'm going to have my 20 grand in here, and it looks like I have a typo in here. This should be 5, so I'm going to fix that. It's not going to be 10. All right, I must have misread that when I did this earlier. So the 10,000 is what was given to you. It told you in 5 years that it was going to double. So instead of being 10 here, this is going to be a 5. Okay. So you go through and you solve. You divide by your 10,000. You get your 2 is equal to e to the 5r. Now rewrite that. When I do that, I'm going to have ln of 2. Remember, the ln is because it's an e. 5r. Solve it. The answer is correct. I just had that year wrong. All right, so again, I apologize for that. Part B, the balance after 1 year. So you're going to use the rate that we found right here, and you're going to use the 1 for the t. So you can see I plugged it in. Plug this into your calculator, you get the $11,486.99 there.